All right, so I think we're going to pick up immediately where we left off from last time. And that means I think pretty much nothing changes in terms of like this info. So -m run, get the carousel going. Where am I at? Let me start by running it and seeing what's broken. I think there is something broken, and it's funny because I was been trying to use AI more to see if like I can use AI to code all the boring bits or like get me 80-90% the way, and then the hard part, the final like 10-20%, just do it myself. And last time I think the AI was getting real lazy. And it's funny, around that same time I saw people posting on the internet Claude being lazy and posting nonsense. So I wonder if I haven't heard of this, but I wonder if there's like a problem where for a lot of the AIs, they have to like reboot them every 2 weeks or something. Because if they let it run for too long, eventually it like starts to rebel. Who knows? But I was feeling like I was getting some of that anyway. Yeah, let's put that like that. And then I do need another one of these up after rebooting my machine. And we're going to do, I don't think it matters that we're in where we are for this. History pipe grep ADB. Darn. Okay, so I don't have the ADB commands that I wanted because I don't have a proper history server or something, I guess. Okay, then we got to come over here and do code dot just to have that slightly pretty view. That's all the OpenCV code that I'm still working on. Where are my docs? Android docs, right? So what do I need? I think I need all the the top ones here. Yes, permissions. Okay. And then let's just give it a launch and we'll see how it fails, because it definitely will. I think it just doesn't return an image. So what it should be doing at this point is it should be using OpenCV to take 5 or 7 images off of the still images off the video off the feed, and then as long as they're similar enough, merge them together, and that's what it's supposed to do. I don't think it's doing that. I mean, I know it's not doing that. I think it's returning nothing. It's collecting all the images, building up that buffer, and then when you go to tell it, hey, merge them and return them, it's returning nothing. So I got to figure out why that is. Give this a moment for it to figure itself out. It's probably, it's going to be a first time run again, so it is, this first build is going to take a minute or so. While that's doing its thing, let me go start looking at the code a little bit. All right, I'm going to need that OpenCV. I don't need this anymore, I don't think. I'll keep it up. So, get enhanced image is the one that is failing. I wonder if it's this buffer full issue. But it should be, when we call process frame, it goes through all these checks and returns false if any of them aren't true. Adds the frame to buffer, and then we check if full. Technically, this little extra check here is not needed. If full, so this is process frame. If if when we process the frame, if we get a true back, then we immediately call get enhanced image. So in that moment, we should get past this here. I guess the next step is let me not trust the AI because the AI was ticking me off. Claude was pissing me off the last time I was doing this. So let me do it the old-fashioned way. I'll add some log statements and see if I can figure out what the issue is, or at least where the issue is. I think that also is part of the piece too, is if you have code that was written by an AI and the code doesn't work, you know, there is the old adage in software of fixing bugs is harder than writing the original code. So if you write code as cleverly as possible, you are by definition not smart enough to fix your own bugs. And I think the same could be true of an AI. So if I ask an AI like Claude to write some complicated code, or I'll talk while I'm doing this, and it writes some super sophisticated code, but that code has bugs in it. Yes, I may be able to ask the AI, hey, this code doesn't work, just fix it. And the AI should be able to say, oh, yeah, I see based on the error where I made my mistake, let me fix that for you. And that works from time to time, like most of the time. But I think from time to time, that won't work. I think from time to time, whatever the AI doesn't have any understanding, but whatever data it's been trained off of where it feels like it understands what you're asking of it, it is beyond the ability for it to fix its own bug, basically. And so I think in those moments, that's where it's important to be able to like go sleuthing on your own, figure out, at least have a deeper understanding of why the code doesn't work. So when you go back to it, instead of just giving it a vague error message that may or may not help it, you can go back to it and say, hey, look, here's the exact line where it's failing. Here's why it's failing. Like, then the AI may have a better chance of fixing its own bugs. So there's a chance I'm in that situation. Let's fix our lighting here. Let's go with that. And I'm going to go with this distance for the books just because I want to see if like the quality is noticeably better at distance. Okay. So we had the permissions. What else do we need? Let me grab logs. This is for getting files off the device. Yeah, here's our logging. I think actually I was in this folder before. Yeah, there's our quest log. Let's shift insert there. Okay, start tailing logs. And then there we go. Image captured. It's syncing. Yeah, I definitely think a piece of this needs to be background processed. But I'll do that after we actually have it functionally working, unless we are like crashing. And if we're crashing, I probably need to solve this sooner. But it should be able to be okay. Did it kill itself? Yeah, it killed itself. All right, I may have to fix that sooner rather than later. All right, let me take a look at this. Let's do tail-f quest log. I think I could pipe grep Godot on that, right? Frame was, oh, right. That's our problem. And that's why I crashed. Whoa. It's not supposed to spit out logs there when I'm done. And then what are our other commands? Just so I have them queued up. So I don't need this file open the whole time. I think getting files off is one. And then killing. Where's our kill command? Here we go. There's the 4 commands that I typically run back to back. Okay, so let's look at this file. Let's go look at quest log. And if we go with Godot, all right, find Godot, close, thank you. Let's see. Still getting this permission issue. I don't care too much about that right now. Starting high quality capture. And then we just started returning empty frames. Return frame was empty. And we got stuck in an infinite loop there forever. All right. What is Godot showing there? Yeah, so return frame was empty. So I was trying to call immediately. Processed frame. And the reason I was calling immediately is part of debugging this is I would like to be able to get these enhanced frames and then save them. Trigger this signal. Which this signal then gets picked up to do a file save off to the local file system. And my hope there would be that while in this while loop, we capture frame, we grab and we get enhanced frame, and every time we call this, you know, the first time it's going to be just the original image. Second time it's the original image plus like the next frame after or a few microseconds later. And if that's true, then you'd be blending those 2 images. So over the course of 2, 3, 4, 5 loops here, we would start to see a slowly improving image. That would be my hope. Or hopefully a very quickly improving image. Like maybe I only need 3 stills before we get a decent image. And so maybe I don't need to stay in this loop for 5 or 7 or 10 times. I can do it after 3 or 4. Or maybe I set it to 5 just for overkill, right? Like at least I have a deeper understanding of where are we getting quality images from. But this isn't working, so. And I think I know the issue. I don't care about that. We always want to run. Always compute this. So maybe it's just working as is. Let's do CD reading room, history, pipe grep, scones. All right, let's do Android first. Excuse me. Okay, so that actually is a pretty obvious bug. And that's just because I wanted the behavior to change. So I don't know what these functions fully do. Frame buffer empty. So if I get an empty image out of this, then that would tell me something. I mean, I'd have to add some log statements to find that. Apply enhancements. Final binarization. Yeah, I don't want to do binarization. Interesting that the AI was smart enough to comment this out for me. Because Tesseract does its own binarization. But I may... Oh, interesting. Threshold binary plus Atsu. Let's see here. Where are my notes on binarization? Atsu threshold after Gaussian. So it's doing a basic thresholding. Interesting. That's doing... Wait, thresh binary plus Atsu. Huh. Okay, but that's cool. If this can do... Because my understanding is if you do a Gaussian filtering. Let's go take a look at that actually. Where was that example? So in the OpenCV docs, they show, you know, so this is a Gaussian thresholding. But then also, so this is Atsu, and they're showing the original noisy image with global thresholding. You know, it's better but not great. Original with Atsu, you know, I don't know. This might even be worse. Like, or maybe the center area is more white, but this outside area is not. But then Gaussian filtering, you know, I guess similar, right? Gaussian, you know, still got some artifacts in the middle, still got some artifacts on the outside, so similar. But Gaussian and then Atsu together, you get almost like this perfect thing. So my theory is to try that for binarization. Out of the box, Tesseract, I think it can do Atsu. I can't remember if that's the default or not. But I want to try this to see if I can get like super crisp characters. Okay, so did that build finish? It did. Let's get our history again, and now this time I need to do Windows. And then we can run again, and things should be faster. Sharpen. So this is Gaussian blur versus Gaussian filtering. I'll have to look up like what that is. All right, that's finished, and now we can run again. Let's get these windows up. This I don't need as much space. Yeah, okay, good. This way I can see all the commands. I can see the window. I can see the logs down here. I'll have the logs here as well if I need them. And yeah, it makes sense that it would freeze because this is actually pretty fast. I mean, I guess this is, it's able to grab 2 per second, which is honestly, well, maybe not as fast as I would like. Let's go with and we'll start doing the tail. Okay, and then trigger. Starting with quality image capture. That seems a little slow. Writing file. Hey, there we go. That worked. So we got frame 1. It's a little bit slower than I'd like. This is going to be annoying if this solves the quality issues, but if it's really slow to do it. I mean, we're talking. To be fair, I guess I'm doing heavy processing every single time. Whereas in reality, I probably would grab, 5 frames or something like that. So it crashed, and it crashed because it's not doing any things in the background. It's getting stuck in this loop. That's disappointing. 1, 2, 3, 4. Let's pull those files off. Uninstall. And let's kill that. So what do we got? Let's take a look. Where do I download to? Oh. Right. Go into my dev folder. And I have a folder here, reading room data. And today would be the 16th. So here's the original. That's the still we're getting off the camera. And then let's compare it to, well, so the first one's going to be, oh, it went black and white. Okay, I thought it wasn't going to do binarization, but I guess it did something like that. So this is, I guess, just a black and white version of the original. In fact, if we're going to judge anything, I would judge, like, how does that, like, that's just blurry nothing. Underneath here, there are words underneath there, but we don't see them. The A and the C and the M both look pretty bad. Hidden is pretty bad. Okay. What happens after 2? How's our quality? Do I notice any difference? Don't know. So I guess really what I need to do is bring up these two. And let's go, what, 200%? Let's go 200% here. Whoa. I'm not sure I see any well, well, okay. If we go even deeper, let's go 300%. Enhance. Okay. And here we'll do it as well. Ah, didn't want that. Okay. So this S looks a little less blurry, I'd say. Interesting. But this T is more blurred. All right, well, it did something. It did a thing. Okay, let's then trek on, shall we? So, next step would be, let's actually do the, let's bring this code back. And so what we want is we're going to call processing frame. Which returns the Boolean. So if this is true, we grab our enhanced image, which in this case I put temp because I just didn't want to, then I was like, hey, ready to process. I thought maybe something would happen there. In case I need to step this through this code again, let's just pull this over here. All right, so now, oops, bring this up. Now I have this weight. I don't know how small that needs to be. Because ideally we're capturing multiple frames in quick succession. I don't even think I want a delay. in any case, down here we have our, like, our temp enhanced image, and we say, hey, look, if we're ready to process, grab the enhanced. In this case, we already know that's true, so go get the enhanced image. I will do this. And what's our count? Frames captured. That's a good point. Actually, I don't need that because we already know it's like hard coded how many frames we're going after. Let's just go with saving enhanced image. Because I can see in the C++ code how many times we call process. Because we have a set buffer size. Once we hit that threshold of enough images in the buffer, then we call this anyway. I might as well put this here. Waiting to capture. Performance I care about a little bit. I do want to see how long these things are. If this step is taking long enough, then I might just delete this anyway. So once we have that, I need to bring this back. Oh, see, I already had that there. It's fine. Let's do that. And then here, we can do that again. Not that it matters. Eventually I'll just delete it, but that way at least this log statement's somewhat accurate. And then, yeah. So now this time, it should go faster. Hopefully we don't crash. Maybe. And let's see now. I'm not going to tail the logs this time. Well, maybe I will. Because I might be able to see how long these things take. I will probably put fractions of a second on this because I do care now about how fast each of these smaller operations is. Globally, I only care if something takes like a second or two, or 5 seconds. But if I'm going to be processing many frames, I need each of those operations to be pretty darn fast. Okay, and then okay, got the logs going. Interesting. Yeah, so this is going to crash. Well, it's not going to crash. You can see the video is still playing. But you can see how choppy it is because these process physics frame updates are only happening in between each one of these little capture steps. And it's not going to die, so I have to kill it. Okay, so it's too sensitive. Even though I have like a still here. This is process frame. What do the logs say? Just waiting to capture. That's about twice per second. And that is because... Okay, well, one thing I can do is I can comment on all of this. And I'll just disable this so we don't get confused. Where is log? That's in our game state, right? So time. Okay, Godot, what's up? Godot. Godot. Why? Really? Okay, no. Not what I want. Godot docs. Here's time. Returns the current time as hours, minutes, seconds, which is nice. I like that. I would like more than that, though. We can change UTC and that's it. Get date. Get date time dict from date time string. Convert the given ISO date time string to a dictionary of keys. This only mentions down to seconds. Hours, minutes, seconds. Milliseconds. Hours, minutes, seconds. Huh. Okay. A little odd. I would have expected them to offer more than that. And I'm sure there's a way I could do it. But now I've stopped caring. Yeah, I probably would have to do something like get ticks and then keep track of the ticks or something. I don't know. That seems dumb. All right, I'm moving on. That is annoying. What do we got here? Okay. Okay, so I can't capture anything at a lower resolution detail than this. Or can I? Where is VS Code? I have a logger here. Right. Did I not bring that over? I have a logger here, and to be lazy, I will bring it over and just rename it because I know there'll be a conflict. We'll call it GD logger. And I know it can do hours, minutes, seconds. Okay. What is it? Python, or not even that, but string format time. Fine. What is the, that's seconds. Time, what are the, what's like the regex for time? Here we go. And since we're talking about C++ code, I do care about this at a lower level than just seconds, I think. Microseconds. Hour, day, month, minute, seconds. What if I just want tenths of a second? Python logger tenth of a second. I just care about tenths of a second. Yeah, but I don't want to do that. I guess fine, microseconds. See, this is doing a cutoff. It's getting like only a couple decimal places. Let's do C++ string format microseconds. It should be the same format. It's the same. It should be like universal regex for these things, because this all looks familiar to me anyway. Huh, they've got shortcuts. Does it not have it? That would be a little odd. I use this piece of code to get a timestamp in microseconds, but it doesn't look like microseconds It's because you don't have microseconds. Millis. Use second. Micro. Buffer. Current time 2. Huh. I thought this would be easier. I might be giving up on this piece too. All right, I've stopped caring. That, great, thanks, amazing. Didn't think it was going to be complicated. Fine. At least I can log though. So let me do that. Okay, so we have, what do we have? Process frame. Convert to grayscale for processing. Better for OCR. I didn't want you to do that. But that's fine. It's probably faster anyway. I mean, if we can grayscale it, that probably improves things regardless. Because it decreases file size. Yeah, it's probably better. Calculate frame similarity. If they're not the same size, return it as 0 basically, floating point 0. Interesting. Where are you used? Oh, we just get the similarity. So if similarity is smaller than the threshold. Okay, so if I go to like 2, or heck, let's just go to 1. So this would be a good place for like GD log. GD logger. Frames to dissimilar. Resetting buffer. Okay. Oh, not what I wanted. Fine. And then for the heck of it, I might just do GD logger processing new image. Not that it's going to matter because I'm only logging at the second level. But, you know, I could see, it might be able to tell me like how many images can I process per second, and then I can do the math from there to figure out how quick these are. Hopefully fast enough. Take a quick breath. And we'll rerun Android because of the extra log statement. Come on, there we go. Is it still doing its thing? Yeah. Let me skinny this up a bit so I can always see that. Just see that little box there. And we'll get our tail ready. There we are. And let me get this ready. Initialization errors, which I'm pretty sure don't matter, but that's fine. And then trigger. No log statements. No, actually, no, we've got processing new image. But why is the buffer not filling? Just processing new image over and over again. But we're never clearing out the buffer. Let's kill it. Interesting. What about buffer full? Where are you doing your check? Let me just take this. Actually, add frame to buffer. GD logger. We have do GD logger not initialized. Doing that now. Easy enough. And then down here, so it should be initialized. How do we do the string concatenation? I think you just do plus, right? Oh yeah, I think I can just do this. Buffer, what's buffer? Oh, this is the formatting of it. Okay. So I think I can just do Here we are. I think I could just do the size, right? I could do bugger. Buffer size is. Can I not spell? MSG. And that should like it. So those will be the two things. When we add it to buffer, I want to confirm what the buffer size is. Because that's got to be the error somewhere. Either it keeps saying that we're not initialized and we just keep reinitializing it over and over again. Or, you know, it's possible, again, I'm going off of AI code for this. This doesn't do what I think it does or what it's supposed to do. So maybe like it just keeps shrinking. It does keep shrinking. That's the problem. I already know the problem. Yeah, because when the AI originally coded this, when Claude originally coded it, it filled the buffer to the buffer size with clones of the same image, which I'm like, why would you do that? Because then we're just going to immediately generate an image. Add frame to buffer. I think this is the problem. And so then the next time we come through, so let's say we did it, okay, and we hit our limit. We get our enhanced image, which should do nothing but just, you know, do the processing, do all the merging, and return. Then the next time we passed in an image, we would come through here. Well, I guess then we would just get another good image, right? Or if we started over from scratch again, our new image would be dissimilar enough. I guess if it's dissimilar enough, then we would nuke it. Interesting that we're not hitting this. So let me up our threshold here back up to 3. Because I'm not seeing this getting hit. And it's moments like these where having an AI code things for me in some ways is slower than if I just did it myself. Because now I got to second guess all the code. And code review it all. And then go understand some weird technique that I wouldn't have done myself, only to find out whether that it was probably fine, right? All right. Now at least we should get a different error. Let's clear this out. Another moment. Install it, and then we'll see. Hopefully this actually works, and hopefully again I see some interesting image quality improvements. Because otherwise I'm gonna have to go down another new rabbit hole of how to figure this out. All right, there we are. Permissions. Let's get approve that. Get the logs going. Start tailing those logs, and get some errors that don't matter. Okay, and trigger. Well, first off, I love how this got smaller. First size, so we keep clipping off something here, which means there's something happening that I don't understand. Let's save off our images. Where's that command? There we are, and then I can just kill it. Why not? How were we on speed here? Starting high quality capture. The formatting's a little different. I should fix that. Yeah, actually, let me fix that. Oh, but it's because it's the standard. Fine. I guess I'll standardize it around something, right? So what is it, year first, and then where's our logger? %y, and then I don't love it, but I'll deal with it. Since Godot seems to have an opinionated way it does dates. Okay. So 24, 24. So all this happened within that first second. So we did the initialization and we processed a new image. Actually, we did that kind of twice. And then in the next second, 1, 2. Oh, still only did 2 images in a second. And then we got to our our 6th image. The buffer was full, so we saved. And so actually all of that took, well, this here, right here took 15 seconds. So gross. We called saving enhanced image. We called this, and then we logged the keyframe count, which is 0 because I'm not actually keeping track of it. So that was 20 seconds. Ew. 20 seconds to get the enhanced image. God damn it. That might be a non-starter. All right, well, at least let's see if the quality was even worth anything. Or are we wasting time here? So let's go up to 300%. We'll do this top bottom. No, I didn't tell you to shrink. There we go. And 300%. I am failing to see any tangible improvement. And this is with a headset that's not even moving. In the real world, the book would be moving a little bit, the headset would be moving a little. I mean, I guess in some ways it's doing some decent averaging. But no. All right, I think we're back to the drawing board then. I think this approach is a failed approach. So darn. All right. Where are Where's my, let's go back to that one conversation with Claude. I think it's this one, right? So I had said I need to grab still images from a video feed, and I want them to be as high quality as possible. If I just grab a still, then the quality doesn't seem to be as good as when I'm watching the video. Why is that? What techniques might I try to improve the quality? Video playback and still frame extraction involve different processes. The player applies real-time enhancements like deinterlacing, upscaling, noise reduction, motion compensation. These algorithms smooth out compression artifacts and improve perceived quality. However, when you extract a raw frame, you get the unprocessed, compressed data with all of its artifacts intact. Choose keyframes, iframes, rather than predicted frames, PB frames. Keyframes contain complete image data instead of just differences from other frames. So they have higher inherent quality. Okay, but we did that experiment and I didn't observe that. It's possible I didn't do that experiment correctly because I had the same similar result of just feeling like I didn't get a better image out. Okay, let's do one more experiment real quick. Hold on. Before I call this a failed experiment. And let me turn on the lights in here. This is going to be really frustrating if I can't get this to work. Disappointing on a number of levels. In fact, I probably just need to put the headset on to do this properly. Should be doing the logs on this right now because I'll bet you anything it's taking forever to... Well, who knows? If it goes fast enough. I don't know, but we were seeing it was taking several seconds to get the images that it needed. Okay, well maybe that was okay. Maybe I held the book steady enough. All the same, let me grab logs off of it, just in case. And then I'll kill it. Oh, let me grab the files. And then I'll kill it. And now if we look at the files, I think I already know what I'm going to say. So if I go like 300, See, that's the problem, is it's like, that's me holding it normally. Normal distance away. Yeah, it just averages things until they're blurred to nothing. Does it even work if I do like, let's try one more time. Just want to see something. I think I already know how the story is going to end, but still. Just want to confirm a suspicion I have. I mean, in theory, if I did some of my OCR techniques on those, you know, you grab like 5 still images real quick, one after another. So that actually might be the other thing, is maybe well, I don't know how quickly it adds into the buffer. But in theory, you would grab like 5 images in less than a second. And one, like that should help things, if I can somehow speed that up. 2, that would then maybe, what am I thinking? Oh, if I like pre-process them with some of the OCR techniques I know to just pull out a bounding box of just the text and standardized around that, and then did the merging technique between them, that might improve this quality a bit. All right, let me actually get queued up for grabbing logs. Okay. Okay, grabbing logs. I'm gonna get this book. Okay, now let's do like the perfect scenario. Let's get it nice and tight and close. By the way, let's get a so filling basically all the frame. So one, performance on this is pretty bad, I already know. There we go. Writing file. And 2, okay, files off. Kill the app. Let me put myself back in darkness because I don't want the lights on the whole time. All right. Yeah, let's see how that quality is. And by the way, yeah, so I already knew. Let's go 200. So, you know, reasonably readable, but only if you hold the book up as like as close to the headset as you can, without like, you know, obviously putting it on the headset, then you get nothing. But you can see like over here, just holding the book slightly askew, you get a bunch of artifacts and ugliness. But that's okay. Let's assume that this was closer to the center of view. That's at least readable by a human. But not this here. That's not readable. But what do we get with this? 200%. Yeah, it averages out to blur. We get absolutely nothing. So we'd actually be better off doing nothing and processing this through OCR than we would by doing this averaging technique. So that's officially a failed approach. Here, let me kill this. That way the headset can go to sleep and recharge a little bit. All right. So frame selection. Let me revisit that briefly to see if maybe that improves things. Um, yeah, it's theoretically possible to do this. Yeah, I mean, I guess if I standardized and cropped it down to just the text. But even then, there might be like slight variations, and then we'd still have the same problem of blurring. Temporal processing. Use frame averaging multiple consecutive frames and blending them together. Apply noise reduction and sharpening filters. Okay. One thing, let me look at. Hold on. Give me a second. Here we go. So this video, so I came across this a long while ago and completely forgot about it until recently. This might be the thing that I can do that'll work. Let's see. Okay, that's effectively what I was saying a minute ago of doing some of the OpenCV techniques I already know for finding the bounding box of the text. So I think if we go back to like, no, hold on. Well, none of these are going to have it, right? These are all going to be, I don't think I have, yeah, I don't think I have the bounding box work here. That's on my other machine. But basically, I was able to capture images and detect the text on the page and then put a bounding box around that text. And then, like, that's, if you did that, that would be step one that he's talking about here. And then that would feed into the next step in the process. Why did you jump to the next video? Didn't ask you to do that, YouTube. Okay. So, comment section. Did anybody else jump in with anything interesting? Let's see. I'm not gonna need to go through any of this. Okay, let's just go look at this GitHub repo. So he's got V1 here. He gets the frames out with FFmpeg. Since it was only 56 pictures, I did it manually by hand. Ugh. So, okay, this is the part that I'm interested in. Okay. Accumulate the pixels. Take the pixels from the window only at the center of the cells and put them into a picture where they are accumulated, which results in this. Hard to read it. So I add a fill algorithm. Basically, I grow all pixels in size until there is no transparent pixels left. V2, same as V1, but does the finding the window position automatically. Where he got 200 frames. Now, I shouldn't need 200 frames to do what I'm doing, right? Again, I should be able to do what I'm doing in 5 frames, right? I would think. Okay, so V1 didn't come out very good, but that's only because he was doing 50. Was it 50? Like 56? 56 frames. 56 frames got him this. 200 frames got him that. And then what technique is he following? Not too much code, right? Oh, okay, he did do a function. But he just calls it load. Actually, hold on. Yeah, he just does this as a whole. Yeah, I don't like that. Not well organized code, but that's fine. So it gets all the frames, the name and frame out of a folder. Find the window position. Keep only some pixels. And again, this is a solution for a very specific, narrow situation. Eight commits. Okay, so yeah, he didn't. All right. Might be worth looking at that. All right. Let me get a general inquiry here. Help me understand. When looking at video of a book opened up, one can read the text pretty well. If you get a still frame from that video, it is much harder to read the text. Why is this? Let's just see what it says with a fresh opinion. Pondering. Still working on it. Okay. Did I ask it an existential question that it doesn't know how to answer? Wow. Maybe they're just down today. Huh. So, yeah, I mean, my thought is just ask it this general question, see what it comes back with, but then really probably understand the frames a bit better. Like, can I actually get a keyframe? Let me ask the same question. Come on, ChatGPT, help me out here. Motion and human visual system compensation. Okay, so ChatGPT is saying that this is a human brain solved problem, not a computer issue. Integrate information over time. Your brain is averaging them out. Micro movements improve perception. Videos, display, scaling. Video is often scaled for smooth playback. If you're trying to extract better quality from a video frame, I can show you tools and methods to combine frames or enhance stills. Yeah. Yes. How would I take a few still frames? Yes. How would I improve the quality of a still frame extracted from a video? Two general strategies. How you doing today, Claude? Wow, Claude's not having a good day. If you have access to multiple frames around the moment you're interested in, you can combine them to reconstruct a higher quality still. This works best for static subjects. Multi-frame super resolution to sharpen and upscale. Frame stacking, image averaging. I think that's basically what I was doing. Oh, tools. So he's saying video enhance AI, real ESR GAN. But for frame stacking, he's saying you can do it with OpenCV. Aligns and averages nearby frames. Okay, so maybe I could do the technique of bounding box around the text, crop down to that bounding box, and then do this technique of frame stacking, frame averaging. AI-based denoising, sure. Extract 5 to 15 frames before or after the target frame using FFmpeg. 2. Align frames, optional. Approach 2. Faster, more basic. You can still do a lot. AI upscaling. I'm not going to do AI upscaling. Sharpening. Contrast adjustment. Okay, so OpenCV. And the book is handheld or gently moving. Multi-frame enhancement gives much better results. So step 1 is better if you have that scenario, which I do. It lets you defeat blur and compression artifacts with data redundancy. Yes, I'm working with a GD extension in Godot 4.5 that calls OpenCV code, C++ code. let's start with no, let's not do that. Let's start with seeing how well we can improve things with a single image. Sweet. Since you're working with OpenCV and C++ inside a GD extension, we'll walk through a practical example of how to enhance a single frame image. Make text more readable. Convert to grayscale. Apply clay, an adaptive contrast enhancement. Denoise, sharpen. Cool. And that wasn't too complicated. This is just simple stuff. So let me take a look at this. Let's paste that there. I do need to, and then we'll get a we're not going to return a mat, we're going to return that. We'll do our reference to an image. I'll bring in this code. Where we'll log. Hold on. Hold on there. Darn it, where is it? What am I looking for? Here we go. That's the example I want. And so we're not, it's can't return false here. We need to return an image. So let's return images instead of false. We'll just return empty. Now we have our CV mat. And then we'll do there. So now we have our current frame, which is going to be a mat, a CV mat. Do the thing, and then sharpened is a mat. So we know we have a mat. CV mat to Godot image. So we've got the building blocks. So all that should be fine. And now I should be able to take this and we'll put it right where process frame is. Where's process frame? There we go. Why are you complaining? Oh, because we have to... Yeah, okay. Got to bring this in. Bind our methods. And it's going to be We have our input image. And yeah, I think it's the same method signature. Okay. Why are you complaining? String is ambiguous. What do you mean string's ambiguous? I've been using it for ages. Do we not have... That's a Godot string. But where did that come from? I might just be missing a Godot import. I am missing Godot import. Namespace Godot. File access, dir access, project settings, packed byte array. Should probably just be... I'm surprised I didn't complain about that sooner. Let's bring that in. Classes, project settings. Oh. My bad. It should be a different type of bind. Interesting that it doesn't complain about any of these, especially for ones that... I guess because it's returning a ref image, but that's still... Where did it get that image from? It got a Godot image. If I replace this with a Godot ... Now it should, in theory, like it. Fine. I don't know if I need all these or not. I mean, I'm pretty sure I don't, but if I bring in a bunch of Godot stuff, will it stop complaining? Oh, wait a minute. This is... gross. Where is GD string used? Oh, right. This is to convert back. So we can send a string back through, which I'm not going to be doing with the OpenCV stuff. Okay. But where is the namespace? I'm not using that over here, right? No. I don't like that it's in the middle there like that. It's weird. Maybe it's Godot : string. Would it be happier? It is happier with that. Okay. If I just do that and just bring in the core stuff. I think there's an error down here. No. I don't know what that red is. Maybe it's just this marker here saying I removed a line. Didn't like it though. Oh, oops. So this probably shouldn't be a string here. I mean, it should be Godot string. Right. And then, yeah, I don't really understand the difference between just a generic, well, I guess it's a Godot class DB. What is class DB anyway? All right, that felt fine. Let's just go with it since it seems to like it. So how are we going to call this thing? Enhanced text image. Okay. Let's go with that. So we know it's going to be that kind of call. We get our current, oops. We get our current frame. And we're going to do like a var. Yeah. So what I'll do is I'll create a new function here for this. Func. We'll call it merge multiple frames. And this will just return void. That's fine. And what I can do actually is I can just leave this as a commented outline. So this was the old version. I can still call it if I wanted to. In fact, I will still keep this here. And then for this, we'll just do improve single frame. Let's just do that. And then for this, we'll do func improve single frame. And again, it'll return void. So this just keeps it organized. Now I can kind of experiment with different techniques here. And then whenever something works, or if I want to go back to something, I didn't really lose it. Obviously, I could always just push code up to GitHub and then not lose it that way, but this is, you know, the quick and dirty solution. Cool. So let us drop this here. I don't need this anymore. I can get our enhanced image that way. Current frame I need to grab. Which is going to be this. This wants a frame count, just because it's going to write that into the file name. I just have that temporarily. Okay, so now I should be able to, when this calls, starting there we go, just so the logs make it more obvious which thing I'm working on. If we're capturing return, that way we can't trigger twice. So we set true, we grab a still frame, capture frame is still just gonna be, yeah, we just go get a frame. I don't even know why we need this extra logic, but whatever. And then we call this, and we get an image back. It liked it, right? Yes. So let's go. Let's give it a whirl. We lost casting, right? Let's cast. There we are. Since I killed the casting earlier, and then 1, 2, 3, 4. There's our permissions. What? Why is this coming up? Okay. Now we've got permissions. Here, I'll go back to the original approach a little bit. Oh, and then 1, 2, 3, 4. Get our logs ready. Continue. Start the logger. Clear. We'll tail. Trigger. Returning improved image. Like, that was fast. It was very fast. I mean, I shouldn't be too surprised, I guess. Kill that. 1, 2, 3, 4. Get the files. Kill. How does it look? This was from just now. Great. Maybe I shouldn't have killed it so aggressively, because I might want to just do another quick experiment. That's the original. You know, I'm not gonna lie, this already looks better. Kind of, question mark? Without binarization, mind you. Interesting. Okay, let's do another quick test. And the lighting in this room is not the best right now, mind you. Although it is getting better. It's rainy outside, but now the sun is coming out a little bit, so it is getting a little brighter in here. I'll get the permissions queued up, and then I'll actually, yeah, let me get set up for actually putting the headset on. So for this experiment, we'll do that. That might not work. It might be a little bit too eager. So I might not, the permissions might not have gone through, which is fine if they didn't. Yeah, permissions didn't go through. Quit, relaunch. Now the permissions will be there. I won't capture any logs. I don't think I need to. Let's see. In fact, yeah, let's hold it like a normal, this feels like a normal distance. And trigger. Okay. And let's see. Logs are a little off, but that's fine. Yeah, let's get the files. I feel like I'm missing a step. Oh, I didn't do the logging, right. And we'll uninstall. Again, probably didn't need to do that. How does it look? Let's go 200 on that. Yeah, see, maybe not. I mean, actually, to be fair, that is not good looking at all. Actually, that might be an improvement. Hard to say. Okay. Let's try it again. This time I'm not gonna like delete it off of the device just yet. Let me just keep it up. Let me turn on the lights in here. I think if there's one thing I could say for early users of the app would be that, hey, you actually need good lighting. I don't think that's fully out of the question. Thinking. In fact, like, how's the even, like, the good scenario? Okay, continue there. I'll even go with like an optimistically good scenario here, holding the book a little bit closer. Let's go with that. Got this here. There we go. Okay. Grab the files. And what are we seeing? So if I go 200 on this, and let's just go upper corner there with the 82, because I think that would be a fair comparison. Consequences of being. So now what happens if I put binarization on this? How does that do? Was that a step that it even suggested to us? So what did it do? We got a mat. We initialized some variables. We did grayscale. By the way, this did like a whole like, well, you know, depends on the kind of grayscale you need. Are they the same though? 2 gray. If it's 3 channel versus if it's 4 channel. Okay, so we assume 3 channel, which I think is probably correct. And then contrast limited adaptive histogram equalization. Okay. Let's denoise it. Let's go crazy. Sharpen. And then where's the binarization step? There was one down here, right? And this is from a different. Okay, so this is the same stuff. Apply enhancement pipeline. So I actually already had Gaussian blur. Interesting. Okay, maybe this is fine. Let's keep on this path. If we do interesting. So this goes to that result. Then we just do an inline denoise. We do an inline. Yeah, then we get to sharpen. This one just keeps pumping things into result. Just keeps updating result. So this assumes result gets passed in. But in this case, it's sharpened that's passed in. And then binary is the one we convert back. Which means I could just create all of these at once. And now our step is a single step. This, by the way, did grayscale, Clayey, denoise, sharpen. Denoise, Clayey, sharpen. Morphological operations. Let me just pull all these up. This also does a clone, input.clone, which I don't think I need to do. I guess this one, it passed in a mat, but this was only called from local. Whereas this one already does that because we're taking an input image and we're generating a new mat from it. So grayscale already happened for these steps here. It was already grayscale. Let's do that. Where is this pipeline? Enhance image. So temporal processing was the step we wanted to skip. Get enhanced image. So we were already doing the conversion, grayscaling, and adding it to the buffer. This is getting those grayscaled images, did temporal processing on them, and got a single mat. But it was already grayscale. Okay, so that's the only difference for now. So grayscale already happened. We then, step 2 is Clayey here, which is, are they the same? Contrast enhancement is a setting. CV size. Cool. Okay. So Claude did a bit more here. Claude was creating settings and passing them in. This was kind of just doing very basic, but let's start with basic. So it was doing create Clayhe, and then set clip limit, set tile grid size. Okay, so this is doing it after. So it's still doing 8x8. And then it was saying set clip limit. This is probably the clip limit. Contrast enhancement. This is saying 3.0. This is 1.2. I kind of like this better, this format of doing the settings. And then it's saying dot apply. This one is doing, it's creating the output. Then it's calling apply. Yeah. Okay. So they're basically doing the same thing, it's just different thresholding. I'll leave this as vanilla for now. Okay. So they're doing them in different orders. So this is doing that second. This one did denoising here. This one's saying denoising should be step 3. Denoising noise reduction strength. This one's passing in 3721. I don't like magic numbers. So if nothing else, I'd rather convert these to variable names. Assuming they're good variable names, right? So assuming noise reduction strength is the correct term for what this is at this step here. But I'll figure that out later. Either way, fast means denoising. Same thing there. They're just doing slightly different ordering. Contrast enhancement, and then sharpening. This is doing a Gaussian blur. This is setting up a kernel filter 2D. Okay. And then this is offering a morphology EX. And then the binarization I brought in. So this is the step it's missing. The orders and the weights of things are slightly different. Let's do make that 5, we'll make this 6. Let's comment this out for now. And then what are we talking about here? Sharpening. Let's bring in this sharpening as well. Who knows, I may have overdone it. There. So step 4 is sharpening, but at least we have we have a Gaussian blur sharpening thing here. And then this can all go away for now. So I am doing binarization. So basically the only thing I'm doing for the moment is binarization on top of what they were already doing. Hopefully that makes things more readable. And then I can experiment from there. Let me run that while I look at this again. So I would look at the docs, figure out what these variables would be. I could then do a apples to apples comparison between this sharpening method and the other one. So I could run them separately. Same thing with, yeah, I could just do a lot of experimentation, right? Just change one thing, run it again, and see if things got slightly better. Take a break for a second. Okay. We'll kill the app there. Okay, that's all good. Ready to roll. So we're at 1, 2, 3. Really, just the 3 steps, because I don't care about the logging right now since everything's working. Like, I'm not actually getting errors thrown. I'm going to like this approach for the moment because it is super fast. We're only working on a single still image, so it's not taking 20 seconds to run. And if it gets us some quick wins, you know, I'll go with the quick wins. I just need a reasonably decent image. I don't even need that much, you know. I just need something good enough that I can probably OCR it. And oh, by the way, for all these steps, I'll probably go back to that. Again, do the bounding box first before doing these improvements. Because the thing about like binarization is going to look at the lightest pixels and the darkest pixels in the image. And to some extent, it's going to use those to figure out which pixels should go to black and which ones should go to white. If you have simple thresholding binarization, then that is just going to draw a line in the sand, and everything above it is black and everything below it is white. We should be doing adaptive. No. This looks like it's a simple threshold. Well, no. We are doing Atsu, which should be better. So it should be smart enough to use like local. I think Atsu will use localized pixels. So you might have a pixel that is relatively dark, but if it's the lightest pixel in the area with compared to the pixels around it, then it would go to white versus going to black, right? And so it is a bit smarter that way, I believe. But all the same, I think it would be better to identify the text, at least know where the text is, crop the image based on that, and then do binarization and these other techniques. And that should do a lot better. Okay, let's give this a go. Okay. You know, it's probably closer than normal, but it's like, you know, a reasonable distance still. Image triggered. Things froze for a moment. Curious how long this whole process is taking. Things froze, but they didn't crash, did they? Don't think so. No, you see, it did take 15 seconds. So maybe it is those steps that are slow. Darn it. Let's leave it up in case I need to capture a new image. And let's see what we got. Yeah, so we introduced binarization. Oh, it crashed and kicked us out anyway. Well, that's fine. So we go 200. Yeah, see. If I zoom out. I mean, and it's not a bad binarization either. Can't really complain about it. Because it's not like there was like a whole section here that got kind of mutilated. Okay, but I can test these things on their own. What if I can do? Ooh. There's a lot of permutations of what could work here. you know, like ideally I would make these separate functions that I could call. So instead of just enhance text, like call these things, and then I could sit here in GD and rapidly change them. In fact, could even like tweak the parameters. Ooh, this could be a good idea. Just kind of refactor it, because then I could just then rapidly change GD script, run, like over and over again, skipping the build step. And that's a little bit better, but what if let's go back to our notes here. For binarization. So this is saying Atsu binarization. So for I in range 3, we plot all the things. So it's really range 3, the third item here. I love how it's doing like the +1. Like, okay, you could. I mean, I guess it's not Python, right? So, well, no, it is Python. So why wouldn't you just do 4? Whatever. Yeah, because it went and got images, titles. You could do something smarter here. So we have blur 0. Okay, anyway, I think it's this. So this is the operation. Atsu thresholding after Gaussian filtering. So we would be doing, it's this. Now this I can't do directly because it's C++ code. But I can at least bring it in here as a code comment. So, Gaussian blur, uh, 550 versus 001. So this did Gaussian blur as part of sharpening, which is interesting. And then this is basically saying, then we do our threshold. So I guess the C++ method signatures are quite similar. This code was not written by somebody who does production Python in my mind. This is ugly. So the method signatures look very similar. So we basically have threshold, blur. What is blur? Gotcha. Blur. Oh, blur being the result of the prior step. Image being the result of the prior step. But then here, yeah, okay. So the way C++ works is, instead of it like assigning the output of the method call to a variable, here we're saying we take the sharpened input, here's our output. So here's the input, the result of blurring, and our output is over here. In this case, it has like 2 outputs. And that is ret3. But the ret3 part gets ignored. And it's really just the... Do we use that anywhere? No. It's not even an input. See, I would hide that with an underscore then. I don't know. Would have to look and see what it does. But this is the result. It's saying th3, whatever th it means. It's really annoying. What are we plotting? So this is the first image. And then our last image here. 3 I plus whatever. Images I times 3 plus 2. Why? Okay, I guess like it's... okay, fine. The word gray. Okay. And then the title, we grab the title. Well, if we look at the first one, it's going to be, the only time we dive into images, I times 3. So if I is 0, it's going to be the 0th. It's this row here. I guess that's all the settings for it. All right, fine, whatever. The point is, this was doing the same thing. Literally the same thing. I mean, it's thresholding 0, 255, thresh binary plus thresh atsu. So this was already doing atsu, just wasn't doing the blur. So if I brought the blur in, yeah, I don't necessarily like this whole declare a bunch of variables up here and then you know, then, I don't know, you end up with a bunch of variables that probably all need to be cleaned up, by the way, and are never cleaned up. What about down here? Do we end up cleaning them up? We have result. We don't clean up result. Maybe it self cleans up. Something to worry about later. Okay, that's our input output. Fine, let me just do it that way. Right, so based on this logic, it would be CV mat blurred so we would take blurred in no, that's the output. This would be sharpened. Yeah. We take sharpened in and we go to blurred. Yeah, this is like because this is like what that two-stage looks like. We then take blurred in. And we get result. And then we should just be processing our result. That way there's no like daisy chaining and then all of a sudden we forgot to, you know, just keep overriding the result as we go. And then we're always returning result. And then we don't have to remember to, we don't miss a line of code somewhere. Okay, so we take the sharpened output, we do Gaussian blur on it, we then take the blurred output and we get our result. And that should be this super cool and optimized. By the way, what are we taking? Yeah, we're just taking in the image, taking in the original image. So that should do this for us. That's original noisy image. This is the Gaussian filtered image. So I will probably test this on its own. Like what happens if I skip all these other steps and we just do these steps here? Like, does that somehow get us an interesting result? Also, this said Gaussian blur 550. Oh, here we go. Gaussian blur, input array, output array, size, k size. And then sigma x. Blur an image using a Gaussian filter. Well, sigma x, sigma y defaults to 0. Sigma x does not default. Sigma y does. Border type for k. K size is our third argument. Gaussian kernel size. Size, width, size, height can differ, but they both must be positive and odd. That's odd. Or they can be zeros, and then they are computed from sigma. Gaussian kernel standard deviation in x direction. All right, fair enough. Well, so that sounds like this is direct substitution. So I may try then setting this to 0 and this to 5. Let's just do some quick experiments. Let's test a little faster, shall we? Maybe I could have 2 windows of this and build them both in parallel. Should be able to do that, right? Since I know I need both of them anyway. I don't know. It's reasonably fast to build. What's annoying, I guess, is those 2 build steps plus then Godot building out for Android. And again, I would kind of prefer to be able to make multiple calls, save multiple images, and then quickly compare them to each other. But the setup of that is a bit annoying. Is it worth doing all that extra setup just for that? Really, this is the slow build step right here. This is the part that's really annoying to me. Okay. Let's see. taking its time. Again, it seems like it's 15 seconds or so. Get the files off. Oh, I keep doing that. Maybe I will move over. Yeah, let's do that. And then this is going to be dev data. Here we are. All right, so this is what we just pulled in. Honestly, that is a lot better, I think. Like if we compare that to the previous one. Anecdotally, I want to say it's better. Let's isolate it and run it again. So yeah, this is where, yeah, what if I just kill all these steps? I'm sure there's a way to do this quickly and block it all out real quick, but whatever. So sharpened doesn't exist anymore. We have our current frame as our input. Fine, let's go through the process of, dang it. What functions did I already have? Fine, you know what? Let's do that. Let's kill that. Oops. Now let's kill it. All right, Claude, I'm going to give you another chance. Let's do a new chat. I have a C++ function below. I'd like to break the multiple steps in this function out into separate callable functions. Please include passing arguments that tune any settings a given step may have. Keep in mind that these functions will be called from gdescript in Godot 4.5. In Godot 4.5, each function should take an image and settings and return an image. Oops. What did it do? Did it like... Okay, good. So it didn't like noisy itself up with a bunch of assumed code. Here's how I'd break them down into separate callable functions. Binarize for OCR is interesting. That it kind of... Did I even have OCR anywhere in here? Oh, okay, fine. Boom, here we go. There's the GD script. Sweet. So there's our class methods. I'll put them as their own separate line items. And then once again, now this file is going to start getting big, but it's okay if these are all their own separate steps and I can call them however I need to. There we are. I am going to need to probably... What's it complaining about? Yeah. So the .h is going to need all these. So what I'll probably do is... That's one, and then all these other ones, they're all going to take an image input. They just need a different name. And I can get those names from here. So if I drop these here temporarily, we've got apply clash, denoise, sharpen image, and binarization. And then finally this last one. And then I should be able to kill those, kill these. Also kill this. Declaration incompatible. Oh, right. Well, that would make sense. Now I got to deal with the settings. So that's clash. Yeah, it's going to be worth it to do this. It's annoying, takes a few extra minutes, but now that means I'm not going to have to rebuild constantly. I can do quick little... In fact, I shouldn't even have to relaunch to the headset. I should be able to just make live code changes, and then everything will work. This one is denoise image. I wonder if these defaults... I wonder how it'll feel about ripping out these defaults. Yeah, okay. And that is sharpen image. So I do like how, yeah, so it's got the defaults, which is sweet. And then I can then pass in non-defaults if I want to. And then everything's close to the function. The one thing I don't like about doing this kind of thing up at the top here is now that means you might be working in a given method and you have to come all the way back up here to be like, oh, what is our default for the dissimilarity threshold again? It's I don't like that. It's better to keep it close to the function definition, in my mind. So then you have the defaults directly declared. That was for sharpen. Unsharp mask sharpen. Not created. Oh, so you guys a alternative. Right. That would be here. Let me kill off these defaults and then get rid of that. Okay, and then that one's happy. Morphological cleanup was not here. Kernel shape, I don't like that kernel shape. I'll probably change this method signature. Binarized for OCR is there. It just has some arguments. Oh, I don't like how it has all these arguments here. Oh, its threshold type is an integer. That's interesting. Cool, everything's happy now. I can build that. And then, yeah, the way it's called. Would be like this. So we got our current frame. Now I can come in here. I can also then actually see how bad each step is, like which steps are the least performant. I could very quickly add log statements for that. It's going to be much faster, and I shouldn't have to rebuild every time at all, period, full stop. Oh, it's camera enhancer. You know what? Let's just call it the enhancer. I like enhancer better. It's shorter. Doesn't really need much. Doesn't need to be fully spelled out. Cool. And then let's clear out those errors. We'll do input image, why not? Has no static typing. Of course it doesn't. But this also then means I can go save off each step. So that's them all chained together. now it has it as like the full pipeline, which I think is probably a refactor and replacement for this method, but I haven't looked at it yet. So I want to mess with binarization. I think that already built, but that's fine. So use Gaussian blur is true. Okay, cool. So let me comment on all these. Oh, it didn't. Huh. Let me just rebuild again. Let me comment on all these. Sure. Let me go 2 of those. And for each of them, that's fine. Let's just do a up here. And then I can get rid of this. And now I can I will comment out those. This is going to be step 1, and this will step 0, step 1. So, got an input image. What are our arguments? We have our blur sigma. Well, it defaults to here. Let's go 0.0. Well, we can try a couple things. Threshold type I'm not going to change. If anything, I was going to change this size. But I'm not going to mess with that right now. All right, those are both true. Now I can do false. Two, 3. So now we've quickly got 4 different experiments of what we're going to get with blurring, of like binarization techniques is what we have. And again, I shouldn't have to rebuild every time now. In fact, I should be able to just live code this, and it should just immediately show up in the headset, which is super cool if that works. Now I can turn all the knobs. And if I really wanted to, I could export those as variables in the editor and then just change settings in the editor and not change code. Assuming this doesn't work, where changing the code doesn't immediately update it, then that would be the next step, would be to export them to like guarantee that that's true. But I'm confident it's going to work. I have been streaming for a bit, haven't I? I just really want this to work. Okay. Permissions, and then headset on. And then we got here. Whoa, it crashed. Why did it crash? That was cool. Did I get any files off of it? Well, what was this? These aren't the files I'm looking for. Okay. Well, actually, what was that file name? 0. That wasn't... Yeah, that was 1230. Yeah, that was a while ago. Nothing. We didn't get an image. So, what happened? Logs. Process out of range. Okay. No errors, right? Nothing telling me about a crash. Fine. Let's run it again. This time we'll actually have the logger going. We'll tail it and yeah, we'll get it this time. Hopefully, or it might just not crash. I've had that happen before too, where it'll crash and then not crash. I also didn't code review at all the code being written by the AI. Maybe I should do that. Crazy idea. So if it's crashing on that first method, oh, well, we're just calling binarization. So permissions, well, let's just take a look since it's available. Can I continue there? And then there's our logs. Might as well tail for the heck of it. There's our crash. So that's a real crash. And if I do vim on quest, we go down to the bottom. Fatal signal 6. Uncaught exception in OpenCV. Assertion failed, case size width. Okay, so by the way, yeah, this one just calls them all. Auto. I wonder what auto means. That's cool. I didn't know you could do that. So I know this worked. So that would be a const ref image ampersand input image. We return an empty image if null. Otherwise we convert to mat. CV mat, current frame, from our input image. We check empty and we return on that, and then we're off to the races. Current frame, we create a new one called processed. Now processed is going to be empty if we don't use Gaussian blur. So if we're using Gaussian blur, no, actually no. We initialize it to current frame. If we're using Gaussian blur, then we do blurred, current frame, processed. Then we do binary, and then we return. Interesting. I do have binary GD log statement here. Yeah, here we go. Binarizing image. Is that the only one, by the way? Binarizing. That's it. Well, you know, I got these errors before, and they did not matter. I remember seeing these before. I don't know why it's happening, but it doesn't care. Assert failed. Case size width greater than 0. Case size width divided by 2 equal 1. Wasn't this something about has to be an odd number? What's our first call? 0. And that is blur sigma, which should be fine because I think I had seen an example of this. Gaussian blur 1.0. Gaussian blur 0. Let's see then. That worked. I'm doing a focused test on just binarization. Calling it with and getting this error. Where is my error? The error is occurring because when you pass 0, which I thought it would, it's trying to automatically calculate the size. It results in an invalid kernel size. Here's refactored code. The fix adds a check. It will skip Gaussian blur step. Got you. Okay, so then the solution is just, we need to do like 0.1. Just go really small on it. That's fine. Doesn't need to be greater than 0, or is it just has to be greater than 1? I could see that being a thing too. Which makes sense based on the logs I was seeing, because I think it was, if you pass it as like a 5 by 5, then you can set it to 0, because then it's not going to infer it from that value. Right. Okay, this should work this time. Or it'll come back and say, like, actually, it's expecting it above 1.0. I think I'm going to stop soon, go grab some lunch. But let's see how this goes. Interesting, I didn't get the pop-up. No, I did get the pop-up. There it is. Oh, that's why, because this crashed. That would be a reason why. All right, let's get the book. Let's see how this does now. Okay. Controller and it crashed again. Probably the same error. And again, we lost our casting. I'm going to go ahead and say that it needs to be above 1. Let's go 1.1 on it. Not that it's going to matter that much, but I guess, you know, comparing a 1.1 to a 1.5, maybe there's something noticeable there. As long as that works, I can worry about fixing it later. And let's get that up, and I'll just be ready anyway. Okay, permissions. All right, let's see here. Give that a moment to come up. Book up. And let's, come on, where's, okay, yeah, there we go. Let's trigger. It still crashes. Interesting. And I assume I'm not going to get any logs off of it. Nope. Let's do this one more time. Oh, and also, I don't need to rebuild and relaunch. What am I thinking? I can just, I already have permissions. So I can just do the logging. Let me relaunch the app, and then I can just go immediately to logging. And then we can try again and see why is it crashing. There we are. Hit sit down. Kill that. Where's my other terminal? New file. Unexpected error. Unspecified, no, sorry. Unspecified error. Atsu mode where source type is 16 in double. Okay. That might be an image type problem. So where did we do binarization before? When we did this previously, well, that's the full pipeline. Here we go. Yeah, so did we have to grayscale it? Ooh, I wonder if it has to be grayscaled. It might have to be. That error looks suspicious in that this is saying this might be the last thing I do. I'm skipping that code change for now and just making sure I don't pass 0.0. I am getting a new error now. OTC threshold requires a single channel grayscale image, but you're passing a 3-channel color image. Yeah, I don't need you to change that for me. Like, I don't need you to force it to be grayscale. Oh, if the image has multiple channels. Okay, fine. That's probably smart anyway. Yeah, okay, fine. For now, though, to just test the performance of this, I could do gray image. And then pass that in. Yeah. I guess that makes sense. That it needs, can't do it with color. All right, so then this probably can go back to 0.1. Because I didn't actually check the error for it. I just assumed it was the same error, that maybe you just didn't like small images. Or a small threshold there. All right, this is literally the last thing I'm gonna try. I just wanna see the results of this running successfully so I can visually compare the results. And then from there, I can then do a lot of knob turning until I feel like I get something decent. That would be my hope anyway. Okay. Longer stream than normal. Nope, not what I wanted. Go back here, bring that up, and this up. Exit out of that. Now let's get the permissions on. Okay, we do have that. Permissions, and then get the book, and hopefully we don't crash this time. Out of abundance of caution, though, I will be prepared for it. That should... Okay. There. And that was reasonably fast, too. It didn't even crash. Cool. Again, I should be able to leave the headset up and do this multiple times. We wrote a bunch of images. It was all pretty quick. And let's see here. Let me get them off the device. There we are. And where's the folder? Here we go. And they're all numbered properly. So if I do, can I do like a bigger carousel or something? View. Can't do like a carousel. I guess that's only something you can do with Apple, maybe. All right. Understandable. Terrible. Absolutely horrendous. Third one. Not bad. And the fourth one's probably terrible. No, actually not. Which do I like the best here? So if we go through these, okay. Let's take it to like 200 for each of them and anchor in the upper corner. They actually all look very similar. How about this down here? To do that, to do that, to do that. Yeah, they're all literally the same performance. I don't really see a difference between them. They all did a similar level of binarization. And the binarization, by the way, was good other than like down here. Which again, so in theory, this type of binarization, it shouldn't matter that like the background is there. So cropping, I would imagine, wouldn't affect it at all. I could just like arbitrarily crop the middle 50% and then do it and see if that does things. In any case, 2, 0, and 3. 0, 2, 3 are all fine. 1, for whatever reason, is garbage. Which is this one. False. Turning on. Huh. Interesting that using Gaussian blur with a high, okay, no, you know what? Maybe that does make sense. Like this blur would have 0 impact if it's false. So it's only when it's true do we see any effect at all. And again, if it has 0 effect, practically 0 effect, we might see like a minor difference between image 0 and let's say, well, it doesn't really matter, one of these. So actually that would be the thing. If we zoom in like 200% here, we might see a difference between these two. But honestly, we set it to like 0.1. So that would, okay, that's the obvious lesson. Now, let's actually do a quick little test here. We should then be able to like live code change this. So this doesn't matter. Because like that doesn't matter, it's false, right? We already know that. This 0.1 doesn't matter. We should be able to do, we've already observed 0.1 doesn't matter. We should be able to do 1.0. True, 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 and then 1.5. So we have 3 versions of this. Well, we already know 1.5 is bad. So let's do 1.25. You know what? Let's go crazy. Let's do 7.5. Yeah, okay. So we did incremental improvements. quarter of a point improvements. If I hit save on that, in theory, it should have live updated this if we're in proper debug mode. And now oops, one mistake I made. 1, 2, 3, 4. So now we should have 5 images. All right. Let's see if that live update works. If so, that's like a very rapid way. It was worth that refactor then. We'll hold this here like this, and there we are. And did we? 1, 2, 3, 4, maybe not? I don't know. Oh, gotta get them off. There's our folder. 0, 1, 2, 3. Whoa. But I don't think this is correct because we should have had 0, 1, 2, 3, 4. So I don't think that. What I should do is make this text. let us pass extra text. Oh, were we not? We should be remote deployed. All right, well, it didn't like it anyway. All right, this is the final little test, and then I'll drop off. So in theory, I could tune each of these individually to my liking and then chain them together and see what the quality is. But, you know, obviously it's going to depend on the lighting and everything, so I shouldn't get too crazy. I should just go for like what seems to be roughly good enough. Like set up scenarios, and then, you know, what looks bad, and then keep tuning it up until it starts looking bad again, and then split the difference between the two and call that average like a good average, basically. But again, this might just be temporary. Like a temporary hack, if you will, to get things looking good when maybe it wouldn't work in most situations. So I can't control every scenario, I guess. Yeah, I don't know. Maybe I can. There we are. And then get the files off. Here we are. Right, so this one doesn't look good. Doesn't look good. They just get worse, right? Even 1.25. Yeah, it's just absolutely horrendous. And then keeping it low and light. Interesting. So this is without it. This is without the blur. Which I guess I probably held the book a little further away. So that's interesting. So I probably should try messing with this size and setting the blur to 0. Because that's what it did in the one example. And I wonder... Yeah. Interesting. But if nothing else, it's kind of suggesting that... Here, let me just kill this all. It's basically suggesting like these numbers are way too high. That like the upper end should, like we shouldn't be getting anywhere near there. We should be at like 0.2, 0.3, maybe, you know, like 0.5 was already looking pretty bad. So if this is original wasn't looking the best. And then 0.5 like already kind of like lost quite a bit. So, but again, maybe that doesn't work for text just because OpenCV suggested it for a noise box like this. That doesn't mean it's good for text. Okay. Well, anyway, that's all I got for today. I might spend some time messing around with this afternoon, see if I can turn the knobs enough to get what I'm looking to get out of them. But, you know, we'll see how that goes. Thanks for hanging.